So in this video we will be seeing how to take advantage of SeTCB privilege. So with this privilege we can act as a system and we can request the tokens for any user. We will be using the LSA logon user, so we need to specify the username password to get that token. So the logon processes like WinLogon will try to create the primary token from the username and the password we supply. So this function can take username and the password and retrieves the primary or impersonation token based on the security principle. And if you have SeTCB privilege, you can impersonate as any user, and within the Active Directory we have curb s4u logon for impersonating any other user. Suppose say web server, if that wants to connect to the database as other user, then it will try to fetch the TGT of that user. So those comes under the delegation, Kerberos delegation. So with this self for user logon structure, we will be requesting the user token for ourselves. So S4U stands for self for user. So we'll be using this structure to pass on to this LSA logon user. So curb logon submit type is we want to request. So this one is curb s4u logon, and the flags is we want to request the identity token, and the first option retrieves the hours the user has been logged on, and the client UPN, so user principal name, and this cannot be null, and the client realm, the domain name, this can be null. So whenever you pass this curb s4u logon to this LSA logon user, this function checks you have the SeTCB privilege or not. If you have that privilege, it will directly retrieve the TGT. And here the information also says that the caller is required to have SeTCB privilege only if one or more following is true, and this curb s4u logon is used. The caller requests an impersonation token. So that's what we are going to do here. So before that we need to register ourselves as a logon process. So we will be running this our whole process under the SeTCB privilege. So let us say register logon process, and the first one is logon process name. So this value will be user32 logon process, and out second parameter is a out parameter. We will receive the LSA handle. So this LSA contains the authentication packages and we are going to use them. We will be using the Kerberos in this video, and the security mode, this value should be ignored. So let's go and register ourselves. So before that we need to create an LSA string. Length, maximum length, and buffer. So let mute buffer is equals to user32 logon process collect this as U8 vector. Logon process is equals to, let's create a new structure object of type LSA string. And logon process dot length is equals to this buffer dot length, and logon process dot maximum length is equals to add 1 to this Okay, now we have set the length. We need to set the buffer value. Logon process dot buffer is equals to buffer dot smooth pointer. Now we are good to go. We have created this LSA string structure. LSA handle and the security mode can be ignored. And the return value is an empty status. If empty status not is equals to status success, then there is an error. Let's go and say the error. Print in hexadecimal format so that we can look up to the empty status error codes easily. Since we are not registered, we are going to return from this function. So after successfully registration, we need to deregister. At the final step, we can use this function LSA deregister logon process. So up to now we are good to go. The next thing is we need to look up for the authentication packages. We need to pass the Kerberos string to get the unique identifier for the Kerberos authentication package. So this function LSA lookup authentication package obtains the unique identifier of an authentication package. So the first parameter it takes is the LSA handle, which we have got from this LSA register logon process. So handle obtained from the previous call, and the package name is these values, and these values are not these exact values. We will be passing Kerberos to this value. I have found the values in the Stack Overflow, Kerberos, negotiate, etc. And the output is the integer to this package number. So LSA lookup authentication package, LSA handle, and the package name is an LSA string. So what we can do is we can copy these and paste here and just change these variable names. Package name buffer2, buffer2, change all this and change this to Kerberos. Okay, for the Kerberos it's just capital K and Kerberos. Buffer2 to okay, now we are good to go. And ampersand mute package name, and let mute package handle. I think this is the number, or it's just a number, it will be 2 or something. And let us say lookup authentication package. Let's go to the return value, and it's the same. Just copy this, let empty status is equals to, and paste here. Change this function name to this, and before returning we need to deregister this LSA handle and returning. Now we are good to go. We have got the package handle, and the next thing is we need to fill this Kerberos S4U logon structure. So there is one catch to fill the members of the structure. So first let's see the members of the structure. First one is message type, and for this Kerberos S4U logon should be the message type, because this structure should be identified by this message type. And the flags is Kerberos S4U logon flag identify. We need to retrieve the token. And the client UPN user principal name Unicode string structure, and client realm Unicode string structure. And there is this line: the buffer member of the Unicode string structure must point to the memory that is contiguous to this structure. So that means at the end of this structure the client UPN buffer should start, and at the end of this client UPN buffer the client realm buffer should start. So these three should be in contiguous manner. So this is the Kerberos S4U to logon in memory, and we need to fill the values here: message type, flags, client UPN structure, client realm structure. And inside this client UPN Unicode string structure there is a buffer, the pointer to this actual string, so that should be pointed to the next to this Kerberos S4U. So this is the UPN, and at this end of this UPN the realm should start. And here we have this client UPN Unicode structure, right? Unicode string structure. The length is the length of this buffer, and the maximum length is length plus 1, and the buffer should be pointing to this address. So the end of this Kerberos S4U, and here we will have the realm Unicode string, and this buffer should be pointing to this end of this UPN. So what we are going to do is we are going to allocate one big buffer to hold all these three values and fill individually all of these values. So I have created a function to do that. It took me quite some time. So this is what it looks like. We will be encoding into UTF 16 bytes and storing in a buffer, and we will be allocating a buffer that is large enough to hold Kerberos S4U logon and UPN buffer and realm buffer. So notice I am multiplying with 2 because these are the U8 bytes, and what we have in the above is U16 bytes. So I am creating a new structure object and filling all these values: Kerberos S4U logon flag identify, and then we are pointing the buffer pointer at the end of this Kerberos S4U size. So my S4U dot pointer starts at this here, at this point, and if you add size of this Kerberos S4U logon, you will get this address. So that's what I am doing here, and the same for the client realm. So for the client realm I should add this one as well to get up to here. So that is I am doing here: my S4U logon and UPN buffer, and I have updated this lengths as well, and then I am writing all of this Kerberos S4U information inside this buffer. So basically here there are all zeros. I am writing this structures members data into this my S4U buffer. So my S4U and pointer to the structure, and write these many number of bytes, the structure size, and after writing the Kerberos S4U structure in my buffer, I will be writing the UPN buffer into this at this point and realm at this point. So my S4U, the base address plus size of curb S4U gives you the pointer to the UPN structure, UPN buffer, and I am writing this UPN buffer and same as realm buffer, and I am returning the buffer my S4U. So that's what we are going to do that, and create curb S4U logon. You need to give the UPN and the realm. So I am going to give administrator @tech69.local. Realm can be null, but this is the realm. Let my S4U. So now we have got this buffer. Now we are ready to, now we are good to go to call the LSA logon user function. So this is very lengthy function. So if the authentication is successful, the username, password and everything is checked, the function creates a new logon session and returns a user token. So since we are using the curb S4U logon and SeTCBPrivilege is on, we don't need any credentials. LSA logon user, LSA handle, and the origin name can be anything, just just give a random string. Like TTY2, TTY3, etc. Origin. So let's say testing origin, something like that. Origin. Okay, we are good to go. The origin. Mute origin. Next one is string that identifies the origin, yes, and where you have the security logon type, we are going to use the network. Yes, we are going to use this network logon, and authentication package. Package handle. Next, authentication information. My S4U dot as mute pointer. So the information in this my S4U, in this one, dot as mute pointer as star mute curb S4U logon, and the information length is my S4U dot length. So here first I thought only the length of the curb S4U logon, but turns out we need to pass the entire buffer length. And the groups, the next one is groups. You can add any groups you want to the token. And the source context, so you can use some dummy token source. Token source, the first one is source name. You can put user32. So what I have done is I have retrieved the process's own token and inspected the token source, and it contains the value user32. Token source dot source name is equals to user32. It should be of the length 8. So we can do like this. So it needs i8 bytes. Dot map u as i8. So this should do. And token underscore source identifier is equals to token underscore source, and the profile information, create a new pointer. And we also receive the LUID for this token for this logon session. And we also receive this token handle, new token handle. We also receive parameter to the quota limit structure. And the substatus. So if the logon failed due to account restrictions, this parameter receives the information about why the logon is failed. So we will say this as logon reject status. Okay, now we are good to go. And the function return value should also be the empty status. So if the function fails, we need to deregister the handle and return. Otherwise we can print the new token handle information. And also we can retrieve the information tokens, get username or get statistics. So we try to execute the get username function before and after impersonation. So we got the token. Now what we are going to do is we are going to impersonate our own token. Impersonate logged on user new token handle. So this function can convert the token into primary or impersonation token as necessary, and after impersonation is over we can revert to self. So first, before we are going to print this username, copy this function, paste here. So I think we are good to go. Now we can print the username. So before impersonation, copy the whole code, and after impersonation, and before that I also running this enable all privileges function to enable all the privileges. So I have given the test1 user the SeTCB privilege, and we need administrator to run this one, run as administrator. We are still test1 user. So here we can see the token handle and read the token ID values and the username before impersonation test1 and after impersonation administrator. So that's how you take advantage of the SeTCB privilege. So in this current process we have enabled this one and requested the impersonation token for administrator. So this is not working for any other user other than administrator in my domain. There might be some problem with that. I highly recommend you to try on your own domain to see if you are getting the impersonation token for any other user. So you should be getting for any other user. So in my case only administrator is we are able to get only to the administrator. So that's all for this video, exploiting SeTCB privilege.